Assalamu alaikum students. Welcome to Learn Chemistry with Waqas Ahmed. Today we are going to discuss how can we find the position of an element in the periodic table if we are given its atomic number or we are told about its electronic configuration. So let's start our today's topic. First thing that you must keep in mind that what things are involved if we want to know the position of an element. If you want to determine the position of an element in the periodic table, you must know about its period, in which period that element is present, in which group that element is belonging, and which block that contain that element. So let's start see how can we determine the three things, that is period, group and block of an element. If we want to determine the period of an element, then it is given by the number of shells. How many shells are present in that element, it shows the period number of that element. Similarly, if you want to determine the group number, then the group number it is indicated by the number of electrons which are present in outermost shell, and these electrons which are present in outermost shell, they are known as valence electron. So number of valence electron will show how uh, which group in which group the element is present. And the block it is can be determined from the type of subshell which is present in the valence shell of that element, or we can say the type of subshell in which the valence electron are present, they will show the block of that element. In order to illustrate these three things, we can take the example of nitrogen. The atomic number of nitrogen is 7. So its configuration can be, electronic configuration can be written as 1s2, 2s2 and 2p3. Now we are going to determine the position of nitrogen in the periodic table. As you can see that this is your first shell, that is 1s2, and 2s2 and 2p, that is showing the second shell. So the valence shell is second shell, so the valence shell will be second shell. Now the number of shell is showing the period number. This is showing the period number. So nitrogen will be present in second period. It is belonging to second period. Now in order to determine the group number is indicated by the number of valence electron. You can see here 2 plus 3, 5 electron are present. So we can say that nitrogen it be belonging to group number 5. Its group is 5th A. It is belonging to 5th A group. Similarly, in order to determine the block, it is indicated by the type of subshell. As P it contains the valence electron, so we can say that nitrogen it is a P block element. It belongs to P block. This is how we can determine the position of any element. We can illustrate with another example. Suppose you are given with another element, that is neon with atomic number 10. So its configuration will be 1s2, 2s2, 2p6. From here you can easily see that this is your first shell and it is your second shell. As two shells are present, so the period number will be indicated by the type number of shell. So its period will be 2. Neon will belong to second period. Now in order to find the group number is indicated by the number of valence electron. You can see valence electrons are 8. 2 plus 6 is equal to 8. So the group number of neon will be 8th A group. It is belonging to 8th A group. And in order to determine the block, You can see the valence electron are present in p subshell, so we can say that neon, it is a again p block element. It belongs to p block of the periodic table. The next example is that of potassium with atomic number 19. So its configuration can be written as 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Now you can see here, this is the first shell, that is 1s2. Second shell contains two subshells, 2s2 and 2p6, and these two subshells are belonging to third period, that is 3s2, 3p6. Then the 4s1, this is your valence shell, and the shell number, that is fourth shell, it is indicating that potassium belongs to period number 4. Now in order to determine the group number, you can see the valence shell contain only one electron, therefore its group will be first A, it belongs to first A group. And here you can see the valence electron is present in S subshell, so the block of potassium will be S block, it belongs to S block of the periodic table. Similarly, we can take the another example of germanium with atomic number 32. We can write the electronic configuration of germanium as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10 and 4p2. From here you can see here, this is your first shell and it is your second shell, and the third shell, two subshell are present here, S and P, and the third subshell is present here. So they are belonging to same shell. Whereas if you look here, you can easily see that the valence shell will be 4s2, 4p2. You can see the shell, valence shell is 4, so the period of germanium will be 4. In order to determine the group number, you can see there are 4 electrons, 2 and 2. 4 electrons are present in the valence shell, so we can say that germanium, it belongs to group number 4th A. It belongs to 4th A group. And when we talk about block, you can see the valence electron are present in p subshell, so the block will be p block. So we can say that germanium, it is a p block element. This is how we can determine the electronic configuration of, we can determine the position of any element from its atomic number and its electronic configuration. Now the next thing, we can also write the electronic configuration of any element if we are given about its position in the periodic table. Suppose you are told that an element, it is present in second A group and it is belonging to third period, and you are asked to write the electronic configuration or valence shell electronic configuration of this element. So in order to write the electronic configuration of this element, we can see that it is present in third period, so it has three shell. The valence shell will be third shell, and third shell has, we shall write two subshell S, 3s and 3p. You will write 2, you can see it belongs to, you can see here it has only 2 electrons, so you will write only here 2 electron, and here it will be empty, no need to write it. So the valence shell configuration will be 3s2. In order to write the complete configuration, we may write 1s2, 2s2, then 2p6, and then it will be 3s2. So this element, its valence shell configuration is 3s2. Similar and here we can also write its atomic number. You can see here it has having 12 electron, 2 plus 2 4 plus 6 10 plus 2 12. So it is having 12 electrons, so its atomic number is 12. And from here we can say that actually the atomic number 12, it is showing that this is a magnesium. So we can also say the which element is present here in this group by writing its electronic configuration. The next thing, suppose you are given another element which is present also in second A group and its period is 3A. I think it is being repeated. Again we can move forward. Another element which has a group number 4th A and its period is 3, and we are asked to write its electronic configuration, and its group is 6A. So in order to write the valence shell configuration, we may write 3s2, 3s and 3p, and we have to distribute these 6 electrons because it belongs to 6A group, so it is having 6 valence electrons. 2 electrons will be present in S subshell and 4 electrons will be present in P subshell. So the valence shell configuration of this element will be 3s2 and 3p4. We may write the remaining or complete valence shell configuration. It will be 1s2, then 2s2, then 2p6. So from here we can calculate the atomic number. You can see 2 plus 2 4 plus 6 10, then plus 2 12, then 16. So the given element, its atomic number is 16. It is having atomic number 16, and we know that the 16 atomic number, it is of sulfur. So the given element is sulfur. So in this way we can write the electronic configuration of any element from its period and group number are given. Suppose moreover you are given a periodic table and an element is indicated. Suppose I am indicating this element as X and I am asked to write the electronic configuration of this X element. So here you can see the X, it belong to second period. It is belong to second period, and group number it is actually 7th A or 17 or 7th A. It is the group number. So whenever I am going to write the valence shell configuration, it is second period. So it is having 2 shell, that is 2S and 2P will be written here. From here you can see it is belonging to 7th A group. So it has having 7 electron in the valence shell, 2 electron will be in S subshell and 5 electron will be in P subshell. So the valence shell configuration of X element will be 2s2 and 2p5, and if I am going to write the complete configuration, it will be 1s2, 2s2, 2p5. So the atomic number of given element X, it will be equal to 9 because it is having 9 electron, and it is representing here fluorine because fluorine has atomic number 9. So in this case, in this way we can easily predict the electronic configuration, as well as we can also find which element is being represented by the X. So this was all about our discussion. How can we use the electronic configuration to determine the position of an element, or how we can use the position of element to write the electronic configuration of given element. It is hope that you have liked the lecture. If you want to continue watching the more interesting videos, please subscribe our channel. Thank you. Allah Hafiz.